Hello everybody, welcome back to Engineering Economics Analysis, and on this video I will explain the rate of return analysis. So the rate of return, it is basically the interest that we earn on an investment, so that the final payment that we get from the investment will have a zero value. So mathematically, NPW equals 0, and the interest rate, so the interest rate I that will give you the NPW equals 0. So that is your rate of return. So I will repeat. So we have an investment, and then we calculate the NPW. What is NPW? NPW is the net present worth. Okay, so we have an investment and we calculate the net present worth of that investment, and then we set the value of the net present worth equals 0. Then the value of the interest rate I that will give net present worth equals 0, that is your rate of return. So the rate of return, I repeat, the rate of return is the value of the interest rate when our net present worth on an investment equals 0. So there are two other names of rate of return. Number one, it is people call it IRR, which is the internal rate of return, or just the ROR, which is the rate of return. So sometimes people will say IRR, which is the rate of return or the internal rate of return, and sometimes people will say ROR, which is also the rate of return. But the basic concept is there. The rate of return, it is the value of I, or the interest that we earn on an investment when the net present worth of that investment equals 0. So remember, NPW, net present worth, it is the same as PV, present value, it is the same as NPV, net present value. Okay? Now, in order to explain how we're gonna calculate the rate of return, I will use two examples. So see example number 1 over here. There is a company, a mining company, and that company makes annual deposit of $250,000 into a reclamation fund for 25 years. If that company must have $10 million when the mine is closed, what is the interest rate the investment earned? So basically, this problem asking for the rate of return. So let's see what we have on this example. So there is a mining company makes annual deposit of $250,000 into a reclamation fund for 25 years. Okay, so as usual, the first step is to make the cash flow diagram of the problem. Okay, so we have 25 years over here, 0 and 25. So the deposit will be 250,000. So it is a negative cash flow over here, and it is 0.25 million. And after 25 years, the company must have 10 million. Okay, so that will be a positive cash flow, and that number will be 10 million. And it is asking for the rate of return on this investment. So the equation will be NPW equals 0, and that equals minus 0.25 because it is a negative cash flow, and plus, it is in million, plus 10 million. Remember, for the net present worth, we are calculating for P. So times P over F I 25. And the value of I from this equation will give you the value of the rate of return. So it's easy to solve. We will have P over F I 25 equal 0.25 over 10, and that is equal 0.025. Okay, so there are three ways to solve this equation. Number one, we use the P over F equation. So remember, P over F, we are calculating P and we know F. So that means 1 plus I to the power of minus 25 equal 0.025. So let's solve this problem. So 1 plus I equal 0.025 to the power of minus 1 over 25. And what is 0.025 to the power of minus 1 over 25? So I'm going to use Excel. So equal 0.025 to the power of minus 1 over 25. Okay, sorry, so that should be to the power of, and that equaled 1.159. So 1.159. So what is the value of I? So I equal 1.159 minus 1, and that equals 0.159, or it is just about 16%. So that is the first way to calculate the I. So your rate of return. So the rate of return is 16%. So this is the rate of return. So this is the I. So this is the IRR, or the internal rate of return. That's the first way. The second way is by doing interpolation. Okay, so when you look up the table, the value of P over F I-25, it is between, so you need to look up the table. So you need to find on the table the value of P over F that is close to 0.025. And if you do that correctly, that will be between I equal of 15% and I equal 18%. So we know when I equal 15%, the value of P over F will be 0.0304, when I equal sorry, the value of I that we are looking for, it is when P over F equal 0.025. This is what we are looking for. What is the value of I for that? And let's say that the value of that I is X, and then when it is 18%, the P over F equal 0.160. Okay. Now the thing that we need to do is to do interpolation. So what we have over here, it will be, so X minus 15, okay, and then 0.025 minus, sorry, so X minus 15 over 18 minus 15, okay, so 8 minus 15 over 18 minus 15 should be equal, okay, 8 minus 15, 18 minus 15 over 18 minus 15, so that should be equal 0.025 minus 0.0304 over 0.0160 minus 0.0304. Okay, so that's the interpolation formula. So X minus 15 over 18 minus 15 equal 0.025 minus 0.0304 over 0.0160 minus 1.0304. And when you solve this equation, you're gonna have X equal 16.125%. Okay, so see that, so the solution is almost the same. So the rate of return is 16%, but which one is more accurate? So the first one is more accurate, because with the method number 2 we use interpolation, but so by using interpolation the result will not be that accurate. So that method number 2. Now the method number 3 is by using Excel. So remember, we have 25 here. So we have 25 here. Okay. So this is the year and the cash flow. And the cash flow in year 0 is minus 0.25. And the cash flow in year 1, it is 0. Until the year of 24. And then the cash flow in year 25 is 10 million. So the rate of return is the IRR. That is the formula in Excel to calculate rate of return. And then the value, we just select all the values, and then you need to guess the value of the rate of return. So I will guess that the rate of return will be 10%. So I will just pick one value, 10%, as my guess. See, this is the IRR. It is 16%. So in conclusion, for problem number 1, the rate of return on that investment is 16%. Now, let's see other example. So let's see. Okay, this is example 1. Now I'm gonna solve example number 6 over here. So we have the cash flow. In year 0, the cash flow is minus 4,000. In year 1, it is 0. In year 2, 2,000. In year 3, 1,500. In year 4, 1,000. And in year 5, 500. So as you can see in this example, so starting from year 2 till year 5, we have a gradient. And that gradient equals minus 500. And therefore, starting from year 2 till year 5, we have two things. We have the annual cash flow, which is equal to 2,000, and then the gradient, which equals 500. Okay? Now, we need to calculate the I, the rate of return, by setting the net present worth equals 0. Okay. So the first thing that I'm gonna do is to draw the cash flow diagram. Okay. So minus 4,000. It is minus 4,000. Year 1, 2, 3, 4, and 5. Okay. See, year 1, no cash flow. Year 2, 2,000. And then year 5, 500. So it is 2K over here, and it is 0.5K over here. Okay. So this is the cash flow. So here with this cash flow, we have the A, which is equal to K, and gradient equal 0.5K. Okay. So the NPW, and we need to set that NPW equals 0, is minus 4K plus 2K times P over A I, and that happened for 1, 2, 3, 4 for 4 years, plus the gradient. The gradient is minus 1.5K. I put just the gradient over here, 0.5K. It should be minus 0.5K. So times P over G I4. But remember, this part of the equation, it happens in year 1, but we need to bring everything to year 0. So we need to times everything here by P over F I1. So this is the net present worth equation for that cash flow diagram. So what we need to do, so in order to solve the equation and find I, we need to do interpolation. And if you look up the table, okay, you need to try, so you need to try the value of I that will give NPW negative and NPW positive. Okay, So you need to try, or you need to find two value of i's that will give you NPW negative and NPW positive. Why negative and positive? Because here the NPW equals 0. Okay, so when you have the value of I that will give you NPW negative, and you have the value of I that give you NPW positive, then you can do interpolation. So in this case, for I equal 7%, and you substitute I equals 7% to this equation, and you're gonna get NPW equal 0.0903. And when you try I equal 8%, you're gonna get NPW equal minus 0.0196. Now what we are looking is the value of I when NPW equals 0. Okay, so I repeat, when you substitute I equals 7% to this equation, and you look up the table, and then you do the calculation, you're gonna get NPW equals 0.0903. And if you use I equal 8% and you substitute I equal 8% to this equation, and you're gonna get NPW equal minus 0.0196. Okay, so you substitute it to, so you substitute the value of I to this part of the equation. Okay, now we can do the interpolation. So here, so I minus 7 over 0 minus 0.0903. Okay, so that's over, and that should be equal so I minus 7 over 0 minus 0.0903, so that will be, then we're gonna have A minus 7 over minus 0.0196 minus 0.0903. And when you solve this equation, you're gonna get I equal 7.82, and therefore the rate of return for this problem is 7.82%. Okay, so as you can see, there is a different way that I do the interpolation between problem number 6 and problem number 1, but if you do both ways, you're gonna get the same solution. I think that is all. Thank you very much.